A matrix is defined as a rectangular array of numbers. This array has a number of rows and a number of columns. So we may let n denote the number of rows in the matrix, and m will denote the number of columns. In that case, we call n by m, or n times m, the dimension of the matrix. And so for a simple example of a matrix, we create an array with the following numbers. I'm just making up some numbers here. 2, 1, 0, minus 2, 1, 3, 5, and 4. And I have created a matrix with 3 rows and 4 columns, which means that the dimension of this matrix is 3 by 4. A convention in matrix algebra is to always let the first number represent the number of rows, while the second number in the dimension represents the number of columns. It's also common to put a parenthesis around the matrix like this, or sometimes we put this kind of parenthesis around a matrix, but this is more common. Another way to represent a matrix is to use Excel. Here I have entered the same matrix that I displayed previously with 4 columns and 3 rows. In Excel, you can also name an array of numbers by using the name box. In this example, I will name my matrix A. Press enter. Then, if I have many matrices in different places in Excel, I can always find my matrix by searching in the name box, find A, and Excel will mark it for you. Here I have painted the matrix yellow. So this is the matrix consisting of 3 rows and 4 columns. I have painted the column number orange. So this is column 1, column 2, 3, and 4. And I've painted the row number blue. So this is row 1, row 2, and row 3. We need a method to refer to the particular numbers inside the matrix. And a common convention is the following. If I have a matrix which I call capital A, then the elements inside the matrix may then be called using the symbol small a with 2 subscript, I and j. And the first subscript, the I, then always refer to the particular row, while the second subscript, j, always refer to the column. And so this a, I, j is then an element of the matrix, where I is allowed to go from 1 to n, the number of rows, and j is allowed to go from 1 to m, the number of columns. So if this is my matrix, then, for example, this number right here is in row 1 and column 1. So it's denoted by row 1, column 1. A1, comma 1 is 2. While this guy, minus 1, is in row 1, column 2. And this guy is in row 2, column 1. Although the notation of using capital A for the entire matrix and small a for the particular elements is not mandatory. It is mandatory to put rows before columns when you refer to a matrix. So keep in mind A, I, J, sometimes we skip the comma between I and J, is the notation for the elements in the matrix. as we move down the matrix, it is the first index that changes, the row index. As we move to the right, it is the second index, the column index, that increases. Also note the consistency with the dimension of the matrix. The dimension of this matrix is 3 by 4. Again, we begin by the rows and follow that by the number of columns. Exactly the same order for the elements is the row, comma, the column. So always in matrix algebra, rows before columns. Here's another example. A is a matrix. As we see, it has 2 rows and 3 columns. So its dimension is 2 by 3. A 1, 1 is -1. That's the element at the top to the left. 1, 2 is the one to the right of -1, while A 2, 1 is the one below -1, and so on. We also have this sort of natural definition that for two matrices to be equal, all the elements must be equal. So two matrices are only equal if they have exactly the same dimension and every element is the same in these two matrices. A few more comments. One is that a matrix really must be rectangular. So these numbers here, which begins with the number 0, that is not a matrix, since I'm missing 4 elements. If I put any numbers into these 4 missing cells, like 0 in all 4 of them, then it becomes a matrix, a 4 by 3 matrix. We should also mention that a matrix is always a rectangular array of elements. No exception here. But you can actually have other things than numbers in a matrix. Even though the most common type of elements in a matrix is a real number, a complex number, or variables representing a real or a complex number. You should also be aware of this type of notation. Here, A is a matrix which is 3 by 2. It has 3 rows and 2 columns. But it's not filled with numbers, it's filled with variables. So I have 6 variables from A11 through A32, each variable representing a particular number. We use this notation when we would like to say that A is an arbitrary matrix, where each element is a variable representing a particular number, but we don't really care what that number is. We can make this notation even more general. If I want to say that A is an arbitrary n by m matrix, so that it has n rows and m columns, I can write it like this. I begin at the top left writing A11. That's a variable representing the first element. Then comes A12. Now in this case I cannot keep on going because this matrix has m columns and m is arbitrary. So what I do is I use ... and I do 1m. A1m representing the final number in the first row. The second row will be A21, A22, and so on, ending in A2m. I use the same idea for the rows. I need to make this a little bit bigger. So I use ... all the way down to the final row, which is then an1, row n, column 1, followed by n2, and then we do dots for the columns, and we have the final element anm. Then we typically do dots like this, and here we do dots going in that direction. N parentheses, and this represents a completely arbitrary n by m matrix, having n times m variables, each representing a number.